This is the video presentation for the ECE Senior Design Team for the Low-Cost Motor Drive Controller. I'm Isaac Nooe, one of the lead engineers on this project. Oops. The scope of this project is to create a low-cost, portable, and modular motor drive system utilizing a microcontroller. This system is intended to be used for departmental outreach events and as a cost-effective alternative to the currently used D-Space motor drive system for power labs here at Michigan Tech. This was a continuation project that furthered the work done by the previous year's team. It was important for the team to understand how motor drives work and the components necessary to drive a motor. Here we see a high-level breakdown of the general method to drive a motor. Also note the various types of motors and different motor drive parameters for each. An important takeaway from this breakdown is the power inverter and control unit. These are two of the necessary hardware components to drive a motor. The control unit is the microcontroller, named the Piccolo, and was selected by the previous team. The inverter is an attachment to the microcontroller, sold separately, and was also purchased or was also selected by the previous team. A comprehensive breakdown comparing each drive method. This table looks at important details of each system, such as overall price, initial setup difficulty, and portability. The team ran many tests on each motor, using the motor drive code provided by the previous team. Through our testing, we found there were necessary updates to be made to each code set, as well as the creation of a motor drive code for one of the motor types. These codes have all been updated, but further implementation is still required at this time. A very important element to this project was capturing speed data outputted by the motor's encoder system. To accomplish this, the team created an Encoder Adapter cable to interface the motor encoder with the Piccolo motor controller. This encoder cable was tested for accuracy by comparing the D-Space's own encoder speed data against the Piccolo microcontroller. Finally, the team created multiple iterations of an enclosure to house the microcontroller and inverter boards, as the need to protect and secure the microcontroller and its connections arose during testing. For future work, full implementation of updated code bases must be completed. A performance test between the microcontroller drive method against the D-Space system will need to be conducted. Improvements to the enclosure design stability and security will need to be made. Red line lab procedures that utilize the microcontroller drive method. Nate Green is the team lead and handled the administrative aspects of the project. I myself, Isaac Nooe, am the lead software designer and led system testing. Zach Niemi is the safety coordinator and helped with research and testing. Mikey Thoresen is the lead hardware designer and helped with the enclosure design and hardware research. We would like to acknowledge the displayed names for their help and contribution to this project. Thank you.